Now that you understand the mechanics of how to work chemical composition problems, let's work through a few examples. A gasoline additive has the percent composition, and it gives us the percents, so we know this. And a molar mass of 98.96. It gives us the molecular weight of the material. What is the formula? So, this is what we're looking for, molecular formula. And we're going to start right there with the given information. And once you have this framework, as before, you can map out what you need to do to get from the starting point to the answer. For this particular problem, let me walk you through it. The first thing is to go from percents to grams. You know the trick there. You just change the percent sign to a G for each of your components. And then to convert grams to empirical formula. Well, the first thing you have to do, of course, for each of those is convert grams to moles using molar mass. Now we have to convert our formula using those ratios: chlorine 2.021, carbon 2.023, hydrogen 4.038. We use our divide by and multiply protocol to get to the empirical formula. The first thing it requires us to do is divide through by the smallest subscript, which in this case is the subscript of chlorine, 2.021. I divide everything by 2.021 and come up with a formula that is Cl1C1H2. Everything is indeed integers, so I'm done. I did not need to use the multiply step. I now know the empirical formula. ClCH2. Now for the next step. Now that I have the empirical formula, I must now go to the molecular formula. Recall that the question gave us the molecular weight of the final formula. So I need to take the empirical formula and determine the empirical weight. So my empirical formula has 1 chlorine, has 1 carbon, and it has 2 hydrogens, giving me a molar mass of 49.47 grams per mole. So knowing my formula that represents the bottom line there, I can see that I know the molecular weight, I know the empirical weight, and I can now calculate N. 49 times what equals 98? The answer is 2. Knowing now that N equals 2, I know that there are 2 empirical formula units in my molecular formula. If I have 2 of those, the final formula is going to be Cl2C2H4. That is the molecular formula. And in case you're curious, that's what it looks like. Moving to the next problem. What is the formula of an oxide of aluminum formed by the reaction of 4.151 grams of aluminum and 3.692 grams of oxygen? Let's look to see what it is that we know, first of all. It's asking us for the formula. I don't really know which formula, but looking at the problem, I can see it does not give me this molecular weight here. So I'm pretty sure it can't be asking for molecular formula. So I'm going to calculate the only formula that I can, the empirical formula. Now, what else is given? Grams of my atoms in my molecule. Well, I have 2 places to put grams. I'm going to take it from the closest one. I'm going to place my star by grams, and I can see now how I'm going to map this problem. I'm going to merely go from grams to empirical formula. So the first thing is to convert the grams of material given to moles, because what? A formula represents moles. Those are mole count. The 4.151 grams of aluminum is going to convert to 0.1539 moles of aluminum. And the 3.692 grams of oxygen is going to convert to 0.2308 moles of oxygen. I now place those two mole numbers in my formula and divide through by the lesser of the two. And I get a ratio of Al1, O1.5. The 1.5 is still not an integer, and I can see that I need to multiply everything by 2 to make 1.5 into an integer. Once I multiply that by 2, I get Al2O3, aluminum oxide. That is the quickest and easiest way to do it. I did, just for the sake of completeness, work the problem where I started with the grams that's just above the molecular formula. You could work through that and convince yourself you would still come up with the exact same answer. Finally, let's work one more. What is the molecular formula of a compound with empirical formula CH2O? Well, this one is very easy to analyze. It gives us empirical formula and it gives us molecular formula. Now, there's no way to get here except for also knowing what? Molecular weight. But if you look back in the formula, if you look back in the question, you'll see it actually gave the molecular weight as well. So to work this problem, one merely takes the formaldehyde, determines the empirical weight of that. In this case, it turns out to be 30. Substitute that into your weight line. N turns out to be 6. And now knowing N equals 6, it's a simple matter to substitute in your final equation. And realize that the formula is going to be a multiple, the molecular formula. It's going to be a multiple of 6. So we can say our final formula is going to have 6 carbons. It's going to have 12 hydrogens. And it's going to have 6 oxygens. And that is indeed the correct formula. By the way, what we analyzed for in that case was glucose.